Hello, welcome to Science Shop. First of all, apologies for the voice. I've got a little bit of a sore throat, but unfortunately we've all got to move on and study, so here we are. Today we're going to be looking at velocity time graph questions from this particular worksheet. All of the questions relate to this graph over here, and we know it's a velocity time graph because it says velocity on the top and time across the x-axis on the bottom. Okay, so if you have a look at the question, it says, above is a velocity time graph of a moving car. Answer the following questions using the graph. At what time was the car stopped? So stopped means that the velocity of that vehicle is 0, and the point at which the velocity is 0 is between 0.7 and 0.8. You see? So that's what we would write here. Between 0.7 to 0.8 hours. That's where it was stopped. At what time did the car have the greatest velocity? So all you've got to do is just see where along this y-axis does the line actually go. And it goes up to here. This is the highest point. And you just go across and it reads 60 kilometers per hour, but it's not saying what was the highest velocity, it's saying at what time. So we have a look down here, and it's from between 0.2 hours all the way to 0.4 hours. So that's what I'm going to write here. So 0.2 to 0.4 hours. What was the greatest velocity? Okay, now what we're going to do is we're going to read off the top, and it says 60 kilometers per hour. And I can't stress enough how important the units are. Make sure whenever you're answering these questions that you get the units perfectly correct. At what time was the car accelerating? Right, we've got a few points here. You got acceleration here, and you have this bit down here. Now this is deceleration, or it's also known as negative acceleration. So technically you've got 3 bits, but if you're talking about acceleration as in speeding up, it's this part and this part. So it's saying what time, so it goes from 0 to, now if you read it down here, you got 0.2. So 0 to 0.2 hours. And also, you got from 0.8 to 1.0 hours. Nice and easy. How fast was the car going at 1 hour? So all you've got to do is you go up here, and it's best to use a ruler. So that's what I'm going to do. Excuse me. So you make a line here, up to the line, from 1 hour up to the line, and then you make a horizontal line across, and you read it across. Now I know it's pretty difficult to see, but the line is going across all the way to 40 kilometers per hour. Notice I haven't calculated anything yet, because all it's asking for was how fast it was going. It was asking for a velocity. All I've got to do is just read it off the graph. It's dead easy. Okay, now for F, this is where I have to actually calculate something. And it's saying, what is the acceleration at 0.9 hours? So 0.9, you've got this line here. Or that point there, that's 0.9, but this whole line, because it's straight, is going to have the same acceleration from 0.8 all the way through to 1.0. Of course, after 1.0, it levels off. Okay, so what we've got to do is we've got to work out a slope or a gradient. It's the same thing. And to work out the slope, it's rise over run. So let's write this over here. Slope equals rise over run. Now, the reason it's rise over run is because you want to work out the acceleration, which is change in velocity divided by time. And that's why we work out this and divide it by the run over here. So let's have a look at this whole triangle over here. So I'm going to just finish off this triangle. I already drew the first part to it. Let's just draw this part here. Okay, so you've got that triangle here. Let's draw it again with green. I know it's really quite hard to see, but this is our triangle. And I'm doing it without a ruler so you can kind of see it. It's a little bit crude there. But it starts off, now if we have a look at the rise, it starts off at 0 and it goes to 40. So 40 up here, 0 down there. 40 minus 0 is the rise, which is 40. And the run, it goes from 0.8 to 1.0. So what you do to work out the run is this number minus this number. 1 minus 0.8, which gives us 0.2. You see? Okay, so just to go over it again, the rise you work out by taking the top point, going across, finding out the velocity over here, taking the bottom point, finding out what the velocity is, and it's this number minus this number. Okay, we're just seeing how much it rises along the y-axis, and it happens to be 40 kilometers per hour. Okay, and the run is going to be from 0.8 to 1.0. You work out the difference by 1.0 minus 0.8, which is 0.2. Okay, then you get your calculator out, and it's 40 divided by 0.2, which equals 200. Now, you've got to be careful with the unit here. Kilometers per hour, per hour. Per hour, per hour. Okay? I hope that's clear. Thank you very much for watching, and I'll see you in the next video. Goodbye.